In the last section, we started writing out some pseudocode to model how Node's event loop works. We are now working on the should continue function, which decides whether or not our event loop should continue running for another tick. So if should continue returns true, our event loop is going to run for another tick. Otherwise, if it returns false, then the event loop will not run anymore and our program will exit back to the terminal. So inside of the should continue function right here, Node.js does three separate checks. Three checks to decide whether or not the event loop should continue for another iteration. We're going to start out by writing a comment that summarizes what each of these three checks are, and then we'll write out a little pseudocode to kind of simulate the check that really occurs. So the first check that Node does when it's deciding whether or not it should continue running our program is to look to see if there are still any functions that have been registered with set timeout, set interval, or set immediate and still need to be executed. So we're going to write out check one, any pending set timeout, set interval, or set immediate. So if there's any functions that still have to be executed through set timeout, set interval, or set immediate, then our program does not exit. It continues running for another tick. I'm going to assume that you are familiar with set timeout and set interval. You may have never seen set immediate before, but it basically works in a similar fashion to these other two. We basically pass a function to it and it will be executed automatically at some point in the future. The second check that Node does to decide whether or not it should exit is to look to see if there are any pending operating system tasks. An example of an operating system task is something like an HTTP server listening to requests on some port. We'll talk more about exactly what an operating system task means in a little bit, but basically for right now, we're going to say that the second check that Node makes is to look if any servers are still listening for incoming requests. So check two, any pending OS tasks, like maybe a server listening to some given port. The third check that occurs is to see if there are any long-running operations that are still being executed inside of our program. So this is going to be very similar to check number two, but there is a distinct difference between the two that will go into great detail over time. An example of a long-running operation would be something like a function call inside the FS module to read some file off the hard drive. So I know that probably sounds very similar, almost identical to this second check right here, but it really truly is a different operation. So we'll go into a lot of detail on the difference between these two checks in just a minute. But for right now, I'm going to add a comment that says, check three, any pending long-running operations, like FS module. And FS module here is referring to the file system module included with Node, which is used to read information off of our hard drive, or write information as well. Okay, so we've now wrote out the comments for the three checks that occur anytime Node decides whether or not the event loop needs to run for another pass. But right now, we only have comments. We don't have any actual code that kind of represents what's going on. So what does it really mean to say that we check for pending tasks or something like that? Well, I think that in all three of these cases, we can kind of imagine that there might be like an internal array of sorts inside of our Node program that keeps track of any of these pending tasks that might be created. So maybe any time that our JavaScript code creates a new set timeout or makes a new call to the FS module, maybe an entry is added to some array to keep track of that task that is currently being executed. So let's create three arrays above our myfile.run contents call right here. And it's going to simulate kind of like bookkeeping stuff that's going to allow us to very easily check in the future to see if we still have any pending operations going on. So I'm going to write out three arrays. I'm going to call the first one pending timers, then pending OS tasks, and then finally pending operations. Then back down inside the should continue function, we can add in some imaginary code that would look at these three arrays right here and check to see if there are still any pending operations in any of them. And if there are still any pending operations, then we'll return false from should continue, or excuse me, we'll return true. Otherwise, if there are no more operations for us to wait on, then we'll return false and our program will exit. So to very easily check to see if there are still any remaining tasks inside these three arrays, we can do something like return pending timers dot length or pending OS tasks dot length or pending operations dot length, like so. So now if any of these three arrays still have any pending operations or any pending tasks inside them, our should continue function is going to return true. Otherwise, if there's nothing else for us to wait on, the should continue function right here is going to return false, and our while loop will exit and will eventually get kicked back over to our terminal. Now internally, Node is going to automatically detect when our JavaScript code that you and I write sets up something like a set timeout call or issues a new call to the FS module. These automatic detections occur even during that initial run of our my file right here. So these arrays are created as soon as we create our program or we start our program at the terminal. And then these arrays get records added to them as soon as you and I start to actually call set timeout or start up servers or work with the file system module inside of the code that you and I write. So I'm going to add a comment right above this line just to remind myself of that. I'll say new timers, tasks, operations are recorded from my file running. So this actually makes a lot of sense. When you and I run a Node program from the command line and say set up a HTTP server, that Node program does not instantly close and go back to the terminal because we set up a pending OS task. We told our server, or we told our program to listen to some port on our machine, and that adds a new task to this kind of imaginary array that exists inside of our program. Okay, so we've now established what causes the event loop to begin and then continue running. So let's pause here, and then we're going to continue exploring the internals of the actual event loop, or what goes on inside this while loop right here, in the next video.